Hello everyone, my name is Ethan Bear, and today I will be presenting on the role of a security engineer and how the SIEM tool Splunk supports that role. We will dive into Splunk's key features and wrap up with a demo showing how it's used in real-time log analysis. First, let's understand the role of a security engineer. A security engineer is a professional responsible for protecting an organization's computer systems, networks, and data from potential cyber threats. They design secure systems, implement security protocols, and respond to threats in real time. But beyond prevention, security engineers also focus on detection, investigation, and mitigation. For example, if a breach happens, they need to act fast to limit damage. To do this, they rely on various tools and technologies, including SIEM, which stands for Security Information and Event Management Systems like Splunk, firewalls, intrusion detective systems, also known as IDS, and vulnerability scanners. Security engineers are also skilled in risk assessment, encryption, and compliance, ensuring that systems meet industry standards. A security engineer wears many hats and requires a broad set of skills. The most important ones include threat detection and response. They must identify and mitigate threats quickly. For instance, a security engineer might set up Splunk to flag suspicious activity like failed login attempts or unusual file access. Secondly, log analysis and incident investigation. Splunk excels here. Security engineers use Splunk to analyze logs generated by network devices, servers, and security tools to trace the source of an incident. Third, automation and scripting. Many repetitive tasks can be automated through scripting, helping engineers scale their response efforts. For example, they can automate the generation of reports for compliance or write scripts to parse logs for specific security indicators. And fourth, tool familiarity. Security engineers are well versed in the tools of the trade, including SIEMs like Splunk, vulnerability scanners, penetration testing tools, and more. Now that we know about security engineers, let's explore Splunk. Splunk is an SIEM platform, a tool that aggregates and analyzes log data in real time. It collects, indexes, and correlates data from various machine-generated sources, servers, network devices, applications, security tools, and even IoT devices. It then makes this data searchable, providing valuable insights for security, IT operations, and business analytics. One of Splunk's biggest strengths is its ability to handle massive volumes of data and provide meaningful insights, often in near real time. For example, when an attack occurs, Splunk can help identify the affected systems and timeline, which helps security engineers respond effectively. Security engineers use Splunk because it helps them with many critical tasks. Real-time monitoring. Splunk lets you monitor system logs in real time. You can see suspicious activities like multiple failed login attempts, unauthorized file access, or spikes in traffic, all of which could be signs of an attack. Next is threat detection and response. Splunk makes it easier to set up alerts. For example, if someone is trying to brute force login credentials, Splunk can send an immediate alert so the security team can respond quickly. Next is correlating events. Security engineers don't just look at one log or event. They need to correlate events across multiple sources to see the bigger picture. Splunk enables this by cross-referencing data from servers, firewalls, intrusion detective detection systems, and more. And finally is incident investigation. After an attack, security engineers use Splunk to investigate what happened, how the attacker got in, and what actions they took within the system. This helps them understand the attack and prevent future breaches. Let's dive deeper. Let's dive deeper into search and correlation using Splunk's search processing language, SPL. SPL is a very powerful query language that allows you to search and filter through massive volumes of log data. For instance, let's say you want to search for failed login attempts. You can use SPL to query data from authentication logs. A simple SPL query would look like, for example, index equals security space source type equals window asterisk, and then next to that will be quotation marks within the quotation marks will be failed space login. This query will pull up all instances of failed login attempts across all Windows-based devices in the security logs. But the power of Splunk comes when you correlate multiple events. For example, you could correlate failed logins with high traffic spikes to see if it's a brute force attack. Security engineers use SPL for more complex searches, such as identifying patterns in data that may indicate a security incident. You might look for multiple failed login attempts within a short time period or correlate this with changes in network traffic or new user account creation. Next, let's talk about dashboards and alert. Dashboards in Splunk allow security engineers to visually track security metrics in real time. For example, a SOC, also known as Security Operations Center, the dashboard might display the number of active threats, or the top sources of network traffic, or even the number of login attempts from different IP addresses. These dashboards help security teams identify trends and spot anomalies. They can customize dashboards to highlight data that's important to them, whether that's user activity, firewall status, or external threat intelligence feeds. Alerts are another critical feature. Alerts notify security engineers immediately when suspicious activity is detected. For instance, an alert might trigger if a user logs in from a foreign IP address, or if there's a sudden increase in traffic. Security engineers can then act quickly, reducing the impact of potential attacks. Next, let's take a look at Splunk in action with a live demo. In this demo, I will 1. Search for failed login attempts using SPL. 2. I will set up an alert for brute force login attempts. And 3. I will create a simple dashboard to monitor security events. First, I will demonstrate how to use SPL to search for failed login attempts. By running a simple query, we can look for any sign of unauthorized access attempts. Second, I will set up an alert for brute force attacks. If there are too many failed logins in a short period of time, an alert will be triggered. This is crucial for real-time threat detection. Finally, I will show you how to create a basic dashboard to monitor security logs and view the alerts in a visual format. Dashboards give you a quick overview of your security environment so you can spot potential threats easily. Hey there, welcome to the demo. For this first part, we're going to be looking in Splunk and we're going to be searching for failed login attempts on this computer. Now, previously, before I started recording this video, I logged out of my computer using Windows L, and I inputted the wrong password a few times so I can get some data on my computer that I can put into Splunk and show on Splunk for the data. So here I am in Splunk. I'm already logged in. What you're going to want to do first is go up here to settings, and we're going to have to add data from this computer. Now when you click this, you have the option to upload a file from your computer. You can monitor your computer using data that's already there, that has been there for a while, and you don't have to put any files in. It just automatically does it. That's what we're going to be doing. Or you can get data from a Splunk user. I don't know anybody else that uses Splunk, so I can't do that. So I'm just going to use monitor. Now, failed login attempts, for this situation, it's going to be local because I misinputted the passwords on my local machine, and it's the same machine that I put the failed passwords in. So we're going to go ahead and click this. And for event logs, we're going to do security because passwords have to do with security, so it only makes sense. This is the only one we're going to do because none of this other event logs have anything to do with the passwords. So we're just going to click next. And here we're going to go to main. Review. Just leave this the same. Now we are done. And we're going to go straight into start searching with this data. And as you can see, we get all kinds of data. But we can't really read what this means. I mean, we can, but we're looking for failed login attempts and the failure reason, all that good stuff. So to do that, we're going to go up here to a new search, get rid of this code, and we're going to do index equals main space event code, and that's going to equal 4625, and 4625 is the number for failed login attempts. So when you're searching, you kind of use this number to filter. Then we're going to do table underscore time of the failed login, and then account name. Oops. We can get the name, and then the workstation name of the PC we're using, and the failure reason, which will give us the reason why it failed. So we're going to go ahead and click enter. And here you can see the time. I put most of these failed login attempts in at the same time, so that's why all these numbers are similar. Account name, this is all going to be the same because it was me who entered all the wrong passwords. You can see my desktop name and then the account name, that's my name. And you can see that going down for all the failed attempts. And then workstation name, you can see it's my PC's name. This is just the default that came with the PC. And then the failure reason, unknown username or bad password. Now this is just the reason why it didn't let us log in and why it failed. So yeah, that's that. Now we're going to move on to the second part of the demo now. Okay, this is the second part of the demo. So now that we've ingested Windows security log data into Splunk, let's take a look at how we can use this data to uncover potential security issues, starting with failed login attempts. As a security engineer, one of our responsibilities is to detect unusual login activity, like brute force attacks. So let's start by searching for failed logins using Windows Event ID 4625. As you can see here, I already have something searched. This was before when I was testing things, but the first thing you're going to want to do is check that your data that you put in is working. So what you're going to do is index equals main space event code equals 4625. Now this is the event ID that shows failed login attempts. So here you can see 16 events. Scroll all the way down, see all the different events, see what's going on, and clearly it's working. The data is processed and we can code our searches. So next, what we're going to do is get it into a spot where we can make a chart out of it. So the code we're going to want to do is index equals main event code equals 4625. Same code we just did. Pretty simple. Next, this is where it gets a little bit more tricky. This line here, it's just getting us a count of how many failed login attempts we have. And then this next and final line, we're going to sort by count. Then we're going to press enter. And here we go. We have our data, the desktop name, and the account name. And we can see the count is 16 for both. So looks like we're good. Okay. Next, we're going to go here. Switching to the visualization tab, I'm going to display this as a bar chart so it's easier to spot the most common targets at a glance. And here we go. So here you can see it's a bar chart. Now we can clearly see which accounts are experiencing the highest number of failed login attempts. This could indicate someone is trying to brute force a specific user. Now in this case, there is only one account, which is me. But say there was a company with a lot of different accounts, you could see which account has the most login attempts and go from there. So we're gonna save this as a dashboard panel. I don't have one, so we're gonna call this one failed logon attempts. And we have it as bar chart. So we're going to save the dashboard. Oops. Must select Dashboard Studio or Classic Dashboards. We'll just go Classic Dashboards for this video. And then after that, we can view the dashboard. As you can see, it just shows us the bar graph we just made. It's a live dashboard panel that updates automatically as new data comes in. This is a very good tool for real-time visibility into login activity. So if I were to go and fail another login attempt, I would come back and this would say 17, not 16. So going back to search, we're going to go one step further by setting up an alert that notifies us of potential brute force attempts. So this code is going to be index equals main, same thing we did before, event code equals 4625, the event ID of course. I'm just trying to make sure I wrote that right. Okay. This is going to be bucket underscore time span equals 5 minutes. It's just a little 5-minute time zone. Next, we're going to do stats count by underscore time account name. This will get us the account name, which would be only me in this case. And finally, it's going to alert us when on this, well, I'm typing where, but when count is greater than 5. So when someone enters a password wrong more than 5 times, this will happen. The search counts failed login attempts for each user within 5-minute time buckets and filters only for users with more than 5 failed attempts in that window. This kind of behavior is often linked to brute force attacks. And we're going to go ahead and press enter. As you can see, here is some of the data. I'm going to go ahead and click Save As, Alert, and we're going to make the title, we're just going to make it Failed Logon Alert. And we're going to go ahead and just do Save in Action. We'll do throttle. Oh, not that, sorry. And we're going to add to triggered alerts. And save. And yeah, as you can see, I have the trial, so that doesn't really matter. I'm just doing this for the sake of the video, but let's go and view the alert. As you can see, here it is. And yeah, this wraps up the second part of the demo. This is where we transformed raw log data into actionable insights using Splunk's dashboards and alerts. In a real-world environment, these tools help security engineers stay proactive in identifying threats and protecting critical infrastructure. Hope you guys enjoyed the demo, and we're going to get back to the slides. Thank you. So why do so many large organizations rely on Splunk for security? Splunk is widely recognized as an industry leader for several reasons. One, it's used by Fortune 500 companies to monitor and protect their infrastructure. It supports frameworks like MITRE ATT&CK, which provides a detailed guide for identifying and defending against cyber attacks. And thirdly, Splunk scales well to handle enterprise-level data, meaning it can ingest and analyze petabytes of data while still providing real-time insights. Splunk's ability to integrate with other security tools and platforms makes it a go-to solution for large security operations. In conclusion, security engineers are critical to protecting an organization's infrastructure from cyber threats. Tools like Splunk empower them to monitor logs, detect threats in real time, and investigate incidents more efficiently. By using SPL, dashboards, and alerts, security teams can take a proactive approach to defend their systems. I hope this presentation has given you a clear picture of how Splunk aids security engineers in their mission. Thank you for watching, and feel free to reach out if you have any questions. Thank you.